All right, I wanted to make this video to help with taking data. A lot of questions were asked, and I'm afraid that you need some extra support in this. So, when you are doing this activity, it's important to make sure you remember that you should not be using 800 grams. You should be using one of these. If you happen to already have data taken with 800 grams, keep it. But I want you to actually explore different masses. So let's say I'm just going to use 2,000 grams. And I should always start with the first fan force, and I'm going to want to take 5 trials, 1, 2, 3, 4, 5. I'm going to show you how to do 2, and then we'll move forward. So I'm loading 2,000 grams fan force of 1. Now, we know that my independent variable is force, and my dependent variable is acceleration. And when I fill this out, my units for force is newtons, my variable is F, my units for acceleration is meters per second, and my variable is A. Now, it's good we have 1, 2, 3, 4, 5 right here. I think that's nice to match this 1, 2, 3, 4, 5 right here. So the first thing we need to do is measure the force that the fan is applying on the cart. And the video does it nicely by setting us up and showing a spring extension. So I'm going to need to make sure that all of these are out and ready. And something to remember is that this force sensor is already set to where when the fan isn't applying, it's at 0 newtons. And after it's being applied, the force of the fan is pushing the spring forward 0.5 newtons. And as we did in the warm-up, we know that since the spring is feeling a force backward at 0.5 newtons, the force of the fan must be moving forward at 0.5 newtons. So that's my first value. Right here, I would put 0.5. Now I need to find acceleration, and we found acceleration by using this relationship. So let's make it a little bigger. It's 2 times displacement divided by the square of time period. So maybe I'll do like fan force 1 calculation, although let's make it smaller. And that means I need to find S and T. So I can then plug it into my relationship. So in order to do that, I need to find how long it takes for the cart to travel some displacement. Now, it might be good for me to just set, let's find out how much time it takes for 90 centimeters. And so I'm going to always want to find the time it takes to reach 90 centimeters. One thing I notice is my ruler is not at the beginning of the cart, so I need to set it up so it's at the beginning of the cart. And then I'm going to try to find the time in which this string is cut. It doesn't have to be perfect. There, that's close enough. And I click reset, and then I press play. And I'm going to wait for the cart to reach 90 centimeters, which is pretty close to right there. I'd say it's about right there. So that's 90 centimeters. So in my S, I have 90 centimeters. And remember, 100 centimeters is equal to 1 meter. So that another way of saying that is 90 centimeters is the same as 0.9 meters. And so I'm just going to go ahead and just always use 0.9 meters because I'm measuring how long it takes to reach 0.9 meters. And the time value I have is 2.7667. So in my first setup, let's just make this smaller because why is it so big? In my first calculation for acceleration here, I have A is equal to, and then 2 times, and my S is 0.9, divided by 2.7667 squared. And I'm going to go to my calculator, and I'm going to go 2 times 0.9 divided by 2.7667 squared. And I should get a value of acceleration equals 0.235, and I'm going to round, so 2.2352. And this is in meters per second. I'm going to take that value, I've copied it, and I'm going to go to my first acceleration, and look, I have at 0.5 newtons fan force, maybe I'll write fan force, I get 0.2352 meters per second for my cart. Now I'm going to say, okay, that's for fan force 1. I now want to do 2, so I click 2. I'm going to click load. Once it's loaded, I'm going to press play to tell me how much force this fan force is applying. I'm going to pause it just so I can see. And I know it's a little bit over 1, but let's just round it to 1. Yep, I already put it. It's already 1. And I'm going to wait for it to be cut. I want to find the time it takes for the cart to accelerate to 90 centimeters. So I need to make sure, boom, I find after this string has been cut. Okay, right there, sure. Reset my timer, press play. My 0 centimeter mark is a little off, so maybe I reset it. Yep, that looks better. I press play, and let's find the time it takes for the cart to reach 90 centimeters. A little too far. Yep, sure, about there. My time is 1.9 seconds, so this is going to be fun. So go back to my calculation. This is for fan force 2. And I have S equals, it's the same, 0.9 centimeters. I'm sorry, 0.9 meters. My time is equal to, and you might hate me, I should have put seconds right there. T equals, and then what is my time? 1.9000, 1.9. I'll just stop there. And then I do my calculation again. Acceleration equals 2 times 0.9 divided by 1.9 squared. Put in my calculator. You'll need to know how to do this. 2 times 0.9 divided by 1.9 squared. And I get an acceleration of equals to 0.4986 meters per second. Hey, it's larger because the force is larger. So the acceleration should be larger. So that matches with my kind of intuition. And I put it there. Now, I would repeat this for fan force 3, fan force 4, and fan force 5. And if you do that and then configure your graph, just like we did before, by just clicking here and selecting your data column, remembering that acceleration is in my y-axis, okay? Force is in my x-axis, okay? And right now, I think I'll only have 2 points, but eventually on your graph, you should have 5 points. And then you'll want to make sure that you include a curve fit. In this case, it's going to be pretty obviously linear. And you'll show this, and it should show an equation, and you'll use this to answer the rest of the questions. Hope this helps. Please contact me if you have any questions.